And in these examples, we're going to be solving an equation for a specific variable. So these are formulas like we dealt with in the last section. And so now we're, instead of figuring out what, in number three, instead of figuring out what h is, what the formula is built for, we can solve for a different variable. And I saw a few of you doing this the other day on the assignment with temperature problems. So you're already ahead of the game. So well done. I bet a lot of you know how to do this already once again. So anyway, so in this case, what I want to solve for is v. So this is what I want to isolate, right? So I want to move everything else to the other side. So it's really the same process as we saw before, the same steps. It's just that we're moving variables and maybe numbers as well, instead of just numbers alone. Instead of isolating the variable and then getting numbers all to the other side, we're just getting everything but the variable to the other side. And so we're going to be moving variables as if they were numbers, right? So anyway, well, let's see what that looks like. Hopefully that didn't confuse anybody. So I'm going to add, in this case, if I want to isolate the VT, the first thing I'm going to do is um, collect all my V's on the same side. So I already have my V's on the right. So I'm going to move everything else to the left. So I'm going to add or subtract both sides. I remember SADMAP. So I'm going to add or subtract first before I multiply and divide. So then what will happen is on the right side, I'll get, or excuse me, on the left side, I'll get h plus gt squared. Then on the right side, we have just vt. So now, the only thing I have to get rid of is just this t, right? And then I'll have v all by itself. So I'm going to divide by t because what's happening here is multiplication when you have v next to t. So the opposite of multiplying by t is dividing by t, right? And so here we end up with v equals h plus gt squared over t. And that's it. Okay. Now remember, if you want to, remember the symmetric property of equality says you can flip it around. So if you like the way it looks better like this, that's also correct. All right. Number 4, the same idea. This time we want to solve for d. Okay. So now this one's a little tricky because we talked about adding and subtracting first, but the problem is, remember, this is grouped inside these parentheses, so I can't just subtract 1 and get rid of it. So this one, actually, I want to get rid of the fractions. And so what I'm going to do is I'm going to multiply both sides of this equation by 3, by the common denominator. And that'll get rid of this 3 here. And now I'll have 3c equals 2d plus 1. And so now it turns back into a pretty straightforward equation, right? So we went from having fractions to being a little scary, intimidating, different, etc. And now it's a nice little cute equation. All right, so I still want to get d by itself. So I have to get rid of the 2, and I'm going to divide to do that, and I have to get rid of the 1. And so remember, we want to do reverse PEMDAS when we're solving equations, so I'm going to subtract 1 first. And then I'm going to divide by 2. And notice how when I divide here, I'm dividing by the whole equation, right? Not just by the whole side of the equation, not just by one term, but by the whole equation. You could also separate and divide by each term separately. That's fine too, but just make sure you divide by everything on that side. So I get 3c minus 1 over 2 equals d, right? And just to show you, if you divided by each term individually, you would get 3c over 2 minus 1 over 2 equals d. So if you put a 2 underneath each of these individually, then it would look like this, and both of those would be correct. Okay, you kind of do a similar thing in here and break up the t if you wanted to. All right.